So this illusion requires a moving object or the animated appearance of movement, which is where we're just turning colored cells on and off on the screen. But the illusion is that the pink dots are spinning around in a circle. Of course they're not. They are turning off one at a time in such a pattern that our brain tricks us into thinking we're seeing movement. But this is the thing. If you stare at the cross in the center, it appears that the pink dots begin to disappear. And if they don't disappear entirely, then you see the pink dots as they swirl being chased around by a teal dot. Why is this? Well, for starters, the pink color is very close to the gray color. There's not much contrast in between them. So when you focus on the cross, the pink dots are now in your peripheral vision. That's the vision to the side of your head where you don't see very well. How far is your peripheral vision? There's an easy way to check that. Take your thumbs, take your arms, stick your arms out in front of you and wiggle your thumbs. Then slowly move your arms apart until you can no longer see your thumbs wiggling. That is the extent of your peripheral vision. You should have an angle of about 80 degrees in front of you that you can see. But you really only have about a 20 or 30 degree angle right in front of your face where you can see things well. Everything outside of that right in front of you zone is your peripheral vision. So anything in your peripheral vision, your brain is going to ignore unless it moves. Now, but even with the movement of the pink dot, your brain's kind of ignoring it. So that explains why the pink dots against the gray background seem to disappear. If they were black dots against a white background or red dots against a black background, the contrast would be greater between the colors and it'd be more difficult for your brain to ignore them in its peripheral vision. But because it's pink on gray, it's easy for your brain to ignore. So why do you see that teal dot chasing the pink dot? That has to do with the way your eyes work. In the back of your eye, you have the light receptor called a retina. That's the part of you that actually receives the light. And it receives the light by a photon literally smacking into a molecule in the cells on your retina, and it forces the molecule to change shape. Now, you can imagine that changing shape requires energy. So a cell that's just seen that bright pink dot has exerted more energy than a cell that's just kind of passively absorbing the gray color of the background. Now, when the pink dot flicks off, the gray cells are still at high energy and very powerful, but those cells that had seen the pink dot are at low energy. And so, because your brain is getting different signals, it translates that as the color teal against the gray. This is called an after image. And an after image is, you've seen them before. You've ever looked at a bright light, you see that kind of weird purpley bruisey color in front of you. And sometimes when you close your eyes, you see after images lingering even with your eyes closed. So that is the explanation for why you see a teal dot chasing a pink dot when all it is a bunch of pink dots flicking on and off.